Hello, this is section 4.2, solving system of the linear equation by the substitution this time. Okay, so finding the solution of the system graphically is not always practical because if the solution come out as non-integers, come out as fractions, yeah, it's hard to find, or decimal. Suppose the coordinates of the point intersects as a fraction or irrational numbers. So in this section, we consider the method does not depend on the finding a system solution visually. This method involves the converting the system of the two equations into the two variable in one equation in one variable by using the appropriate substitution method. Thus we call the substitution. So solving the linear system by substitution. Number one, solve the either of the equation for one variable in terms of the other, which is one of the equation is already been formed. You can skip the step one. And substitute the expression found in step one into the another equation. So this will result in an equation in one variable. And then we are solving the equation like chapter 2 using the order property of the solving equation. And then back substitute the value found in step 3 into the equation from step 1. Simplify, find the value of the remaining variable. And then check the solution, of course. Make sure that you got the right solutions, okay? So we have to actually check it out. Is it any of the equation is solved for x or y? So, but it is. The equation already solved for y. So which means for the so in equation 3, you get 2x but 3y, but instead of the y, you can use a 2x minus 8. You see it? So it's from the equation 2, but instead of the y, right, you can use the 2x minus 8 because 2x minus 8 is the same as a y. These are the equivalent. And then you have now the one equation. Then you can solve for x. So multiply by 3 inside, get 6x minus 24. 8x and minus 24 equal to 16. Add 24 both sides. 8x equal to 40. And divide by 8. And then I have an x equal to 5. Now, it's about order pair of the solution. So you need to find the y. So okay, let's put it this way. So we still need to find the y because x is already founded. And I think I want to use the equation number 1. So y is now 2 times x is a 5 minus 8. 10 minus 8, which is equal to 2. So y is a 2. So solution must be order pair. So y and 2. And then you must be plugged in to check it out. Alright, in number 2. Okay, one of the equations need to be solved for y. So there's always a better equation to solve for y. So this time, I think I'm going to pull out the equation 1, 2. I'm going to solve for y. Because y is a positive term. So pull out 4x plus y equal to 4. So for y means subtract 4x both sides. And then your y becomes negative 4x plus 4. Now I'm going to call this a 1 prime. So because it's the same as a equation 1, but different loop. So now what I do is I'm going to plug it in negative 4x plus 4 into the equation 2, okay? Don't plug in the same equation, okay? So plug it right here. So now what you get is you're getting a 3x, but instead of the y, you got the negative 4x plus 4. Which is equal to 3. So this is from the equation 2, but instead of the y, I was using the negative 4x plus 4. So this is all for x. So 3x, and then multiply by negative, you got 4x minus 4 equal to 3. And then 7x minus 4 equal to 3, and 4 both sides, 7x equal to 7, and divide by 7, and then x equal to 1. But that's not it. We still need to find the y. And then you have to decide which equation is the best. So for me, it's equation 1 prime. Because 1 prime already solving for y. So you just need to plug it in 1 in the x place right here. So y, I want to do the 1 prime, which is y equal to negative 4 times 1 plus 4, which is a 0. So your solution is 1 and 0. So it's easier to find, okay? Alright, equation 1 and 2, but equation 1 is already the solve for y, which means I can plug it in 5x minus 13 into the y here in the equation 2. So which means I can get 2x plus 3y, but instead of the y, I can use 5x minus 13, which equal to 12. And then I can solve for x. So 2x plus, now multiply by 3, 15x minus 39 equal to 12. 17x minus 39 equal to 12. Add 39 both sides. I got 17x equal to the 51. And divide by 17. I think this is a 3. And then, still need to find the y. Then I want to use the equation 1 this time, because this equation 1 is already solved for y. So y equal to 5 times x is a 3 minus 13. 15 minus 13, which is a 2. So your answers are 3 and 2. Now, the number 4. Now, we need to find which one is the best equation to solve for. So this time, equation 1 and equation 2. But I think I want to use equation 2 to solve for x. You don't have to solve for y as always, okay? So I'm using the equation 2. But I'm going to solve for x, because x is a positive 2. I'm going to solve for x, not to use for x. Solve for x, which means x minus y equal to 3. Solve for x means plus add y both sides. And then I am getting the x equal to y plus 3 or 3 plus y. Doesn't matter. I'm going to call this a 2 prime. So now I'm going to plug it in. Y plus 3 into the equation 1. Always different equation. To x right here. So which means you got the 3 times of x. But x is now y plus 3. And plus 2y equal to negative 1. And then we are solving for y. So multiply 3y plus 9 plus 2y equal to negative 1. 5y plus 9 equal to negative 1. Subtract 9 both sides. 5y equal to negative 10. Divide by 5. Y equal to negative 2. And then we still need to find the x. As you notice, well, I want to use the equation 2 prime because it's already solved for x. So x equal to negative 2 plus 3, which is a 1, okay? But xy order pair, so you have to put 1 and negative 2. Alright, let's look at the next page. So use the substitution method to identify the system with no solution or infinitely many solutions too. So we call that the linear system with no solution is called the inconsistent system, which is a no solution. So inconsistent means there's no solution. When solving such a system by substitution, both variables are eliminated. A false statement such as 0 equal to 5, which is not true, that means no solution. But recall that the equation in linear system with the infinite many solution too, called the dependent, which is they're same. So you can say that, okay? So let's do as problem number 1. So number 1 and number 2. So I need to use a substitution, okay? So what I needed is this already the equation 2 nicely already for simple y. So I'm gonna plug it in this one in y here. So I got 3x plus y, which is a negative 3x plus 3 equal to negative 5. And then 3x, and then open up the parentheses, we got this. But 3x minus 3x cancel, so you got 3 equal to negative 5, which is not true, right? That's why no more x. So you have to say no solution, which means they are parallel lines. Alright, the second one, I do the same thing. So number 1, number 2. And so I'm going to plug it in. 3x minus 4 in the y place here. And then I get 9x minus 3y, which is 3x minus 4 equal to 12. I got 9x minus 9x plus 12 equal to 12. But 9x minus 9x is 0. I got 12 equal to 12, which is true, right? So that means you have to say there are infinitely many solutions. So sometimes you're losing all the variable, which means it's a case of the no solution or the infinitely many solution. Okay, thank you for listening.